Okay, so it's March 1st, 2026. Uh, this video is to showcase Project Blue. And what is Project Blue? So, before we get into that, the issues that I had with microcontrollers is that they generally don't have a display. There's no HDMI, there's no VGA, there's no nothing, right? Generally, they're headless. So I decided, well, hmm, is it possible to make like a Windows 95 style operating system for a cheap microcontroller that's like, say, close to like $5 to $10, right? Like, so a super cheap microcontroller that has like an okay kind of level of capability, built-in Wi-Fi, a little bit of RAM, things like. Is it possible, right? So that you can see what's going on, not only just write code and run the code, but that you can actually build an operating system for it where you can see what's happening. So it actually puts out video, right? And that's how Project Blue got started. And I started this project back in May of 2025, and I didn't work on it for like 4 months or so, 4 or 5 months. So I lost quite a bit of time, and there was a lot of issues along the way. But here we are today in beta mode. So Project Blue is a real-time operating system for the ESP32-S3. The minimum requirement for the hardware is 8 megs of flash and 8 megs of PS RAM. So anything higher is great, and you absolutely need an SD card. Um, so the board comes in two flavors. The first is real-time desktop, which doesn't need uh, an HDMI or VGA connector, and it basically gives you about 30 to 60 frames per second near real time. That's doing some really funky compression, some really cool stuff to make that happen, and we'll look at that today. And the other is VGA output with or HDMI output using a small dongle. And the frame rate, because you don't have the network constraint, the bandwidth pipe constraint, and the overhead of that, you can get anywhere from 30 to 100 frames per second. So games are absolutely possible if we use the acceleration that's built into the board to do some funky 3D stuff, 3D math, and things like that. So we'll take a look at that. So let's get started. We'll connect to the board now. The operating system is on the board, and it shoots over the display via the web browser in the remote setup. And the other setup is just direct to VGA. We're not going to look at that today. We're just going to remotely connect to the board. Okay. But before we do, let's disconnect. Let's see. Basically, the control station is just a browser page, right? So if you ping it, it tells you the latency, and that's very important because if the latency is really big, your connection to the board is not very good. You'll have a bad experience. You'd want to have a low latency. Unfortunately, today I'm going through my phone, so it's not like a home router with high bandwidth and stuff like that. So you don't need that. I mean, if I could do this on a phone, I mean, it just tells you that really you don't really need much for the system to work, and this just shows you your FPS. I'm gonna go full screen, and right off you have your menu bar. It shows your apps, your games. There's about 9 games. Your scripts, which I'll describe about your system. So let's go to system. Oh, and of course your Wi-Fi. So it's using the Wi-Fi stack on ESP to scan and put it out here. So this right away feels like, if we go to control panel, uh, let's make the status bar visible. Let's change this to Eastern. Let's set an image for the background. Girl, let's open. Let's apply. Okay. So this feels more like an operating system. So the the status bar is movable. You can move it anywhere you want. Um, right now, I'll just put it up here. So basically, this system, my system has 16. Actually, let's take a look at that. Let's go board. So this is system diagnostics. It picks up your board, right? So it tells you this is an ESP32-S3. It has 16 megs of flash. And this is your SRAM. We've eaten up most of the SRAM, very little left. Generally, these boards only have 512K SRAM, but half of it is usually taken up by. I'm using IDF for development, so it's taken up by RTOS, right? That's the underlying free RTOS. Eats up most of it. Very little left. The PSRAM is really what helps you here. We have 8 megs, and we have almost 7 megs free, which is really good. Flash is 16 megs. I have an SD card connected. It's about 32 megs SD card. So the system reads it like this because the formatting. This is your IP address. It has a coprocessor that's inactive. We can turn that on to do some really cool stuff. We'll get into that later. VGA output is on. I could turn that off. In fact, you know what? Let's go turn it off. Control panel, VGA disabled. Okay, apply changes. Yes. Okay. So if we go back to system tests, now we see VGA is off. Wi-Fi power is max. The temperature for the processor, it has a temp sensor. We're picking that up. It's about 42 Celsius. And we can physically connect a USB mouse and keyboard. I've done that, and it'll pick it up if it's there. Um, so these are the tests for your diagnostic to make sure your board is running properly. So I'm going to start the test, and I'm going to go through all of them right now. Okay, so you have your DMA, it's close to 12 megabits per second. This is your RSSI for your Wi-Fi, your ping, you know what that is. Network speed test about 10.1 megabits per second, and so on and so forth. I mean, there's a whole bunch of tests. You can turn them off. Let's say you only want to do the ping test. Boom, boom, click test. It'll just run ping. Okay, there you go. So this is really important because you want to make sure that if you want to know your latency, because you're running this operating system, you're streaming it over the network, right? So this is very, very important, and this gives you a quick snapshot as what your hardware is, what you're dealing with, what's going on, making sure the operating system is picking up everything properly. So this desktop is being streamed from the ESP32-S3, a $5 to $10 board, and it's doing all this in real time. Look how fast this is. I mean, this is incredible. This desktop is not in a browser. This is in the board, and it's actually sending this information. So if you ever purchase like if I put this for sale or whatever, a download, whatever, and you guys get one, you'll see that this is a real thing. But it's not BS. There's no trickery here. Like, this is for real, right? Um, let's go to terminal, for example. So if we type help, these are the options. You can do dir, obviously, and this is listing everything on the SD card, right? So, and the mouse scrolling, it does work. So you're scrolling things by the mouse, right? So let's go clear. Let's go top. So I just want to show you, it's like a hybrid. Like I wanted to make the terminal like DOS, and then have a whole bunch of Unix commands that a Linux command that I really like. So top is very important. Gives you the task name, the state, and the stack, and all that stuff. So let's exit. Okay, let's go back to terminal. Boom, boom, boom. And let's go help. So let's say we want to, I don't know. I don't know if you guys remember the DOS command is called tree. And what, what it does, it basically graphically shows you what's in the directories in like kind of like a tree structure. So I put that in there as well. Okay. What can we show you without taking up too much time? The wget command. Okay, wget. Google slash robots text. Well, first of all, before we execute that command, let's go to File Explorer. Let's make sure that if we go star.text, so these are the text files there. So if we close it and we execute this, fail to open connection, robots.text, google.com, robots.text. Let's try it differently. Let's do it this way. Text. Okay, worked. Okay, excellent. So if we go File Explorer, we go start. So the File Explorer supports wildcards, and there's the robots. And if you open it, if you double click it, it'll open up the correct applications to look at it. So this is Google's robot text, and I'm scrolling with my mouse. So, and I could also click, and I could also use the up and down keyboard keys as well. But I like scrolling with my mouse. So yeah, I mean, this is a real thing. This definitely works. So you have a terminal, and yeah, I mean, it's pretty much like an operating system, right? So does it do multitasking? I would hope so. Let's go to the text editor. Let's go text editor. Okay, this is text editor. Okay, and we support true type fonts. So Times, Ravi, Ariana, Garmont. Let's take a look at Times New Roman, large color. So this is running on the ESP32-S3, guys. Like, seriously. Times New Roman. And let's go to font, Ravi, color blue. This is Ravi. And in the future, we'll have more fonts, but this is just a test, right? Just want to show you in beta mode what we can do with this thing. Font, Ariana, size, huge, color. This is Ariana. Okay. And it's buther smooth, like it's so fast, it's insane. It's probably faster than your computer, I would say. Faster than my general computer, anyways. And we have all the edit functions, find, copy, replace, and all that. If we go Garmont, my favorite. Yes, large color. Brown. Yes, and it doesn't look that great. Brown. Let's go huge, and disco. This is D Garmont. My favorite. Okay, so we have a terminal up here. We have a background running, which really, I mean, it sits in PS RAM, so you're saturating the bus, but you're still able to do all this stuff. And let's say we want to listen to some music. Let's go. I don't know, I have a playlist, but really, if the music's not in your playlist, you can just go load, and you go music. These are all the musics that I have. Let's listen to some AC/DC. You can stream to Bluetooth. That's not enabled right now. Okay, so you can see that this is amazing. I mean, for the ESP32-S3, I mean, it's incredible. And because this text editor now supports rich text document, not just plain text, we can do these things. We can embed images. We can do true type fonts. This is like a scaled down version of Microsoft Word. So, and you see how fast it is, right? You can do some painting here. You can see it's like literally there's no lag. Let's say we want to do red. We want to do rectangle, right? And then we want to fill it with yellow. Boom. We'll do circle. Okay. I'm going to fill that with blue. And let's say we want to put some beach in there, right? Okay. Put images in here. It's like Microsoft Paint, right? Like Paint and stuff. Um, oh, I accidentally filled it with blue, and I could just go undo, and I could go text, green text, sunshine. Okay, so I mean it's very capable, right? And you can save that and blah 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 and all that stuff. So that's Paint, that's text editor, image viewer is just stunningly incredible, incredibly fast, incredibly fast. Um, I mean, you can go one to one, or you can scale it to the window. Uh, so let's see. So, for example, this is a very big image, but it's scaled to the window right now. So you can scroll, and you can see the quality, right? 16 bits, 800 by 600 is the desktop. So it's not 640 by 480 anymore, and it's not 8 bits. It's 16 bits at 800 by 600. This is incredibly fast, right? Um, I mean, one to one. These are very big images. We can go out like this, right? I mean, this is a real thing here. I mean, look how fast this is. It depends on your network, of course, but it's incredible. Look at the quality on the display, right? So it's very beautiful. I think it's incredibly beautiful. And it does animated GIFs as well. So if we go to animated GIFs, right? So yeah, and so the decoder. I mean, we're decoding the image and playing it, and then streaming those images in real time onto the browser. So it's not the browser doing this; it's the actual ESP32-S3. And the thing about this board is, like, we're decoding, natively decoding. Um, I'll show you. So if you go to File Explorer, uh, these are the formats. Start.jpg. So we're decoding JPEGs. Let's say, I don't know, this. I don't know what image this is. JPEG, right? We're decoding. Oh, and by the way, so we have file attached to the application that it's in. So if you double click on the text, so if I go start text, right? If I double click on here, it'll open the editor. So it's linked to the editor, right? So if I go star.bmp, so we're decoding BMPs on the board. And we're doing it really fast because it's hardware accelerated using SIMD math. So it's like super fast. We have, we're locally decoding PNG. So we support PNG, right? That's it says 1.8, but it's PNG. Um, and PNG GIF as well. Uh, gift. Okay, yeah. So this is a GIF. So basically, that's really amazing because we're doing it so fast, right? And we're able to pump it over the network really fast. And this is your File Explorer. I mean, it's basically the root of your SD card, right? So I have a whole bunch of stuff on here, and it's really super fast. I would say this is faster than my computer because it's very highly optimized, and it's running on less than half a mega RAM. It's pretty incredible. The thing about this File Explorer, like, let's say we want to put a file onto the SD card. The way to do that without taking the SD card, because your board is connected to the network, is you just click Wi-Fi server. It gives you an IP address. So if I go to my browser and I type in the IP address, which is this, hit enter, now I have access to my SD card. I could copy. I could right click on that and say save link as, and I could save this file on my computer from the SD card, from the board in real time, and it'll save it. So if I go to desktop, and you can see what's on my desktop, right? So if I save this, let's call it, I don't know, picture pick. All right, save. So here it is. So I just saved that from the board to my SD card. Sorry, from the SD card to my computer, right? So now let's say we want to go the opposite way, and we want to send a file. That's big. Let's send something really small, like moo.txt, for example. Okay, so let's go to here. Before we go there, let's make sure that file doesn't exist because no cheating is allowed. So we'll stop the server. We'll go star.text. Okay, so these are the text files on the SD card on the root. There's no moo.txt here. Okay, so if we go Wi-Fi server and we go to my computer, so that's the board. So let's go connect to it. We're connected to the board. Let's go choose file from my computer. Master moo.txt. Select upload, and it's done. because it's just a text file, right? But it's really fast. And so I'm going to stop the server now. I go start. It does wildcards. So there's mu.txt. This is whatever the contents of that is. So it's really fast. I mean, to move files between your computer and the board, like it's a picture, it's a script, it's a video file, whatever it is. It's very very quick. So what else? You saw the audio player here. Music. Where's it? Music. So Banana Ram from the 80s. Yeah, I mean it's quite incredible. So how does that happen? How do we do music? So the board is setting the file, playing the file, and sending it as a binary over the network, and the browser is decoding and playing it. So it's, I mean, you basically have a full multimedia system here. Um, so you saw File Explorer. You can do copy, paste, rename. Let's make a new directory. Let's call it hello directory. Yes. And hello directory. Where is that? Hello directory. There's nothing in it. So let's say go back to the root. We want to put this one. So copy from uh, copy to, so hello directory. Yes. Okay. And we just copied it. Now we want to delete it. Yes. And here's the thing, like before, if we go to a directory, let's say scripts, right? And there's a whole bunch of files, and you want to delete it, I would have to select a file, click delete, select a file, click delete. Now, because we updated the code, we can actually select a whole bunch of files and click delete. You'll see 5 files to delete. Yep. So now we don't have to go click delete, right? Um, so it's an updated file explorer, and it's really fast, as you can see. It's a real-time, near real-time operating system, true Wi-Fi. And this is a native web browser, so it's called a Quantum browser. And this browser, I mean, it took me a while with the tools to put it together, but it's quite incredible. Let's go to BBC. Go read. So it's a text. It was a text-only browser, and now it does text and images and downloads for PDFs and images and stuff like that. It's quite incredible. You can actually use this browser. It's a little bit slow because remember we have half a mega RAM and very limited PS RAM, right? So this is BBC, buddy. This is BBC. So I mean, and it does mouse scrolling. So I'm scrolling with my mouse right now. I mean, this is incredible. This is incredible. And it has a near infinite scroll capability because it only renders what's on the screen. But all this stuff is helped by the SD card as a cache, right? So there's a service called Gina.ai. It helps you to have a text, convert a website to text. But I do more than that, right? We're doing pictures as well. Sometimes the image don't come up. You just hit refresh and I'll fix it right up. Say we want to click on this article. It's a little bit slow because my network's a little bit slow. My internet is through my phone, and it's a little bit slow. But there you go. You're reading news on the BBC in real time with pictures and text and all that stuff. There's no video and audio, but as you can see, it decodes the image in really, really fast. This is not slow. This is not painware. You're not going through any pains here. I mean, this is incredible, right? So, yeah, I mean, this is a real thing, man. If you guys ever buy a board or download the software or whatever, you'll see that this it's a real thing. Um, so I'm not gonna go through the web player, but why not? So the web player, it's it's incredible. You can stream videos over the internet. We can't do YouTube, but we can do because of security things that's blocking it. But let's see a specific video here.
There people, I have made the video
So this is a real thing, man. It's a real
uh,
thing.
the presentation from Carmen Stewart whistleblower from
And it scales the video in
NSA.
real time.
She was their employee long time, and
Okay, so it's a real thing. I mean, this is a real thing, and you'll see that. So for PDF, it took a while, but I'm able to. We're able to decode PDFs. So if we go to downloads, there's a test PDF file. So this is native. This is being done by the ESP32-S3, and it's using the rendering system that has been created here for Project Blue, and it literally uses the SD card as a swap. And because there's not, you can see PSRAM just dropped to 2.1, right? So let's help it a little bit. Let's free up some memory. So if we go Control Panel, clear the background, eats up a lot. Let's reset the board, help it a little bit. Remember, this is beta, right? So it's still pretty cool. Okay, so we're back. We have our memory back. So if we go to QPDF, downloads, test. Let's see if it'll work now. It's a very, very memory intensive. Yeah, there you go. There you go. And it's really fast. It's really fast. Not as fast as your computer for rendering PDFs, but it's full color, right? So this is native to the board. This is not your browser doing it. This is not your computer doing it. This is the ESP32-S3 doing this. Look at the quality on this, man. I mean, it's just incredible. Yeah, it has to go through and render each page because it's just a microcontroller, right? It's 240 megahertz microcontroller, but that it can do this, that we can do this with Project Blue is just incredible. I mean, I don't know anybody else that's doing this, and I don't know anybody else that can, render PDFs in real time on their ESP32-S3 or a web browser or anything like that. Yeah, we have a mail program. So let's go accounts, connect. It does POP and IMAPI, and it does Gmail. It has Gmail support. So get all mail. We have 233 emails. We're not going to get all 233. We'll stop. But I just want to show you, man, that we can actually do these things here. So that's the content of it. So if I go, there's an attachment here. Yeah, we do attachments too. Moo.text download. You should have a pop-up that says your attachment's been downloaded. If we go to File Explorer, we go start.text. There's actually, it would be in downloads, right? Yeah, there it is. Yeah. So, yeah, this is the attachment that I sent from Google. So, I mean, it's literally, it's incredible. So we have a text editor, a Paint Studio, image viewer, audio player, file explorer, calculator, right? 25 times 400. And you can resize this bad boy any way you want to fit on this. And it's near real time, as you can see. We have a web browser, web player, PDF viewer, and a mail program. So it's a full feature desktop, right? And a status bar. And the games. So before we start with the games, which is my favorite part, let's take a look at the system capabilities. Okay, so let's click on this 3D demo. Now, this is sim accelerated, so we're using the hardware in the ESP32-S3 to render this in real time. These are calculations doing in real time, right? So this is the hardware rendering that we have for Project Blue that we've developed. It is incredible. It is absolutely incredible. I mean, this desktop, if you look here, we're hitting close to 30 frames per second. It's 24, but I mean, it's just because of the network congestion, right? But it's literally absolutely incredible. Um, so I'll stop that right now. I'll just take a. We'll go to system capability. Okay, so yeah, this is the Extensa, right? DS3. It's dual core, right? And it's running at 248, but it does have some vector extensions for AI. So we repurpose AI for what we just for what you just saw. So we're 800 by 600, 30 FPS. Um, we're using our PS RAM very heavily, as you saw, SD card. Mouse and keyboard is coming from your computer, but we can do it local as well. You can plug it directly into the board. And I've developed an SFX system that does MP3 playing and game sounds and stuff like that. So this is really the meat and potatoes of it, the hardware acceleration. So we do fast fill, fast copy, alpha blending, glass effect, like see through. We can do all that, and we've done it. Um, sprite blitz, line drawing, 3D projections. This stuff allows what you just saw, right? And we obviously have a whole bunch of games. So let's go back here. Let's go to chest.
HS match is in progress. Quiet please. It's White's move.
So I didn't like the boring chest, and I decided to have the board. It's not just doing the AI and all this stuff, but it's also doing audio as well. So it shows you the move,
It's Black's move.
right? So
It's
for example,
White's move.
if I click my knight,
It's Black's move.
you can see how fast
It's
it is,
White's
right?
move.
Right?
It's Black's move. Takes. White. Knight.
And I just love that.
It's Black's move. It's White's move.
Right. So, anyways, you get the idea, and your pieces are. Let's say I want to sacrifice. Anyways, it's gonna take too much time. And my favorite game when I was a kid, Missile Command, ported to. It's a little bit different, a little bit better, I'd say. So if you look at the FPS, right, we're hitting almost 30 FPS right now. Boom. And you can move this window around, right? I mean, this is real time stuff. This is for real, no bullshit here. This is the ESP32-S3 doing this. Like this is not the browser. This is the board putting out this video of this, of the OS and of
It's
the
a
game.
missile attack. It's a
Right?
missile attack.
I put some. So the sounds are in the SD card. It's being piped through the sound system. Next level. So you can multitask while you play. I mean, it's really crazy. This is a real thing. There's no BS. Boom. Your girlfriend's probably here. You gotta protect her, right? You gotta shoot those missiles down so they don't get her.
It's a missile attack.
Because you guys have
It's a missile attack.
because you guys have a hot date on Fridays. Okay. Anyways, enough of that. So that's Missile Attack. That's chess. Space Invaders, the classic. And these games are not just for the games. It's to really demonstrate the capabilities that has been built into Project Blue. All the hardware acceleration, all the video, all the audio, all the multitasking. This is a real operating system to do real things, right? Um, Look how fast the gameplay is here, right? I mean, it's incredible. And you hit B for bomb, and so the other game I thought it was too hard because it, it was just too hard. So now you have bombs. You press B, and kills the. It helps you out a little bit. But yeah, I mean, it's incredible. The Space Invaders, Star Patrol. So yeah, these guys. So these guys are procedurally generated. It's different every time. Oh man, this guy's hard. Stop shooting me, big balls. Oh, yeah, game over. I died. Anyways, you can see like what's this. This is like a real arcade. Okay, this is like a real arcade on your ESP32-S3, baby. All right, look at this. And I add a firing on here, so you can fire. I mean, this is arcade style, man. It's really hard to keep it going. But you can fire when you hit a certain amount of cubes and stuff. So. It's just incredible. I mean, this is like arcade style. Arcade games being streamed over the network, right? This is not on VGA or anything. VGA will be even faster, right? So the firing just helps because like it's really hard. Yeah, right on. Breakout. Takes Breakout to the next level. And this is my baby kind of thing, my little baby here. This is it really showcases the capability of Project Blue. Check this out. Look at this. I mean, if this isn't arcade, I don't know what is. Oh, I just died. This is generated in real time. All these asteroids, right? Look at this. This is like insane level gameplay. This is like an arcade being streamed over a network in real time. It's a beta, right? So there's little glitches and little problems and stuff. But I mean, look at this. And I'll just stop it here. I'll take off the taskbar because that slows it down because it only has so much power, right? And this game takes a lot out of the board, like it taxes it to the max. So let's go control panel. Let's go hidden. Okay, so we took off that. So that's gonna help. Let's go back to Stardust. Yeah, okay. I'll say it's a little bit better. This is very taxing. Man, it moves really fast. You press the WSB key. But, I mean, this is Project Blue. This is what's we're capable of with this board. I mean, this is like real-time 3D, hardware accelerated. It's doing 30 frames per second over the network, right? I mean, it's just incredible. And it's procedurally generated, so it's all random stuff. It's never the same. Like, this is the big boss. Oh, God. Got shields. gotta kill this guy. He's not shooting for some reason. Generally, they do shoot and their weapons are different, but this time they didn't shoot. So. It's gone. Okay. Level 4. Triple shot. I mean, this is real-time 3D. I mean, oh my goodness. This is arcade-style quality. Project Blue, man. Yeah, I'm very proud of that game. There's still a lot of work to be done, but yeah. And if you guys remember the initial Nintendo system, I never had one. So I wanted to recreate Duck Hunt. You don't have that point and shoot. There's my little boy. Boom. Okay. So I'm gonna put the set the background. Okay. I'm just gonna reset. There we go. Okay. Different background. I'm gonna put the visible. There we go. Save changes. Okay, make it a true desktop again. For that game, it taxes the board so much because there's so little resources on the ESP that you want to turn off the background. It eats up like 1 meg of PS RAM and turn off this and all that. But for Duck Hunt, let's turn on all the stuff. This game doesn't tax it very much. Yeah, so it just showcases what's possible. What's possible on this board, and it goes on and on. So that's Duck Hunt, and I'm gonna take off. I don't have to take it off, but I'm gonna. I'll try it with it, but not a good idea. So I don't know if you guys remember Battlezone. Uh, this is the ESP version of Battlezone. Butter smooth, man. Butter smooth. Butter smooth. Bad guys here. Yeah. Okay, so I'm gonna take it off. So also control panel, clear, apply. Okay. And I'll take that off as well. Battlezone. It's a new addition to the game lineup. Yeah, I mean it's just butter smooth. It's so smooth. It's incredible. Yeah, it's 3D. It's like the old days. Now where's the bad guy? Oh, we got a bad guy here. Let's go up to bad guy. And they do shoot you, by the way. Yeah, you got shields there. Let's go around. Where are you? There you are. Mystery saucer. It's so smooth that. Where's that saucer? Somebody's shooting me. Who's shooting me? Okay. Anyways, yeah, it's just butter smooth. So these are the games that's possible on Project Blue. I was gonna make something like a Mario Kart because the system is so fast. So this is what it would look like, but I didn't get a chance to finish it. Um, yeah, it's this is what Mario Kart would look like on the ESP32-S3. Not as nice, but if you do it on the VGA board, it'll look like butter smooth and really really nice. There's a video player, so let's get the set background. Okay, put the background back. Okay. And there's all kinds of Bluetooth and stuff that I'm working on. But again, it's just beta, right? So let's play, let's open a video file. So I've seen people do the on the ESP32-S3. I've seen them do. Let's see, where's here we go. I've seen them do. I've seen them do MJPEG, and with MJPEG you have to separate the audio and the video, and make the window really small and stuff like that in order to see that video. I've seen people do that, and I've seen them pumping out the LCD port, and it looks okay. It's not too bad, but I've never seen anybody do MP4. Project Blue does MP4 natively, so it does it on a board. It shoots it to the browser, and the browser decodes it. So this is real time video, right? This is not bullshit. This is for real. This is for real. So it's playing an MP4 file. An MP4 is video and audio, right? So you don't need to separate the two. It's just one file. I've never seen anyone do MP4 on this. Yeah, I mean, this is a real thing. It's quite incredible. Um, that's the video player. So now we get into what I really want to do with Project Blue, right? And that is something like Boardmaster. So what Boardmaster is, here, let me just delete this board, is using Project Blue for controlling IoT devices. I'm just going to plug in an ESP32 board that has the special firmware. So what this allows you to do is basically treat IoT devices as objects, but visual objects. So remember, I told you that the microcontroller generally don't have displays. Well, this is why I would want it to have display, because this is actually running from the board. So it tells you your IP, the board type, your flash, your PS RAM, your temperature. Does it have an SD card, and is it online? Well, this is the master board. Now, if we go and we scan for boards, so we found a remote board. It's an ESP32 board. We added it, right? And now it doesn't have an SD card. Has 4 megs of flash, no PS RAM, and let's give it a name. Remote IoT one, I don't know, whatever. And you click here. It has a whole bunch of stuff. So now, if you go GPIO, you can set GPIOs. This is just the initial. You'll be able to do it much nicer. So you can't see it, but when I set this high, a blue LED turns on that remote board, right? So the network command, if you go to log, um, I'll just turn this off, get back on. So if you go to logs, it has exactly what's going on there. You can save your logs and stuff like that, save logs and all that. And boards, you can delete board, scan for board, you can flash the boards and things like that. So what this does is it basically this is the master board that's putting out this desktop, okay? And what this board is doing with this board master program is it's connecting to an ESP32 board that has a special firmware, and it can control it. So now this board, the master board, can control multiple boards, and you see it in a graphical way. That's very easy to use, right? So now you can you can change GPIOs, you can read ADC. So example, if you do a scan, it's basically you're logging the values from your analog to digital converter for sensors and stuff, and you also have a scope, right? So I'm going to put more functionality in this, but for right now we can graph the incoming. So what we're doing on the master board on Project Blue is we've connected to a remote board through the network, and we're capturing the analog to digital sensor information in real time. We're graphing it in a real way. So this this operating system and this project gives you this capability, right? And you can read it from whatever pin, right? Turn it on and off. So you're controlling IoT devices, and that's what this is about. Um, and you can have more than one, right? Right now I only have one board with that special firmware, but you can have as many as you want. So you can have something for your security system, you can have something for your robotics, for whatever. And these boards can be near or far. They can be near within your network range, or they can be over the internet, and you can control it that way. So LCD, if it has an LCD, you can pump a picture from your master board to there, right? Sleep functions, right? You can put the board to sleep. Uh, you can ping it, right? It'll tell you the network status. You can reset the board. So I'm going to reset it right now. And when you reset it, you can see it's rebooting and the link goes down, right? And wait for it to come back up. Oh, it's back online. So I'm going to disconnect it. I'm gonna unpower the ESP, the remote ESP board, and it's unpowered. So it takes a few seconds to detect that it's been unpowered. So now it's offline and it's red. Now I'm going to put it back. I'm going to power it again. Uh, so the board is powered now. It takes a few seconds to detect it. Now the the master board detected that it's online. So this is really powerful. You can do some really amazing things controlling IoT divided devices with board master. And because it's you know because it's on Project Blue, you're able to see and interact with that information in a graphical way, and that's what I wanted for that. We already went through a system test, so I'm not gonna do that. We went through terminal. You know what that's all about. The control panel. We have a little calendar, um, rootin' tootin' calendar, because you gotta have a calendar, just like you have to have a calculator on an operating system. Um, and basic ID. So this is a full-fledged basic interpreter. So compiler. So you basically write code in basic. You can open files, text files and stuff, save your code. You can change the font, right? You can change the color of your font, um, and you can run your code, right? So you can't see it, but my board is blinking blue right now. Um, So this is the output of what you wrote. So what BASIC allows you to do is not just tap into like system information like the IP address and the heap size and the peripherals like GPIO. It basically allows you, it gives you within Project Blue, it gives you a full uh, programming ID on the microcom on the ESP32-S3, running this desktop within the desktop. So you're able to access all the peripheral functions, and you're able to do so programmatically. And you can save your scripts um, on your SD card, so you can have multiple programs and you can run them graphically, right? And because you can connect to the board with any browser, right? You can connect to it from work, you can connect to it from an iPad, from a Mac, from a Linux machine, from a laptop. You can connect to it from your phone, and you can do things, right? And that's the whole thing behind Project Blue is that before, if you want to interact with your microcontroller, like your ESP32 boards and stuff, you have to do it through either IDF, which is a little complicated, and this program is built on IDF, by the way. I love IDF. Or you have to do it um, through Arduino, and Arduino is nice, but it's not graphical, right? It's text. So you write code and you run the code, and your board is headless. Well, this gives you a real. It gives it a graphical desktop, right? So you're able to do things on board. So this is actually the board putting out this operating system, this desktop, in real time. Now we're able to programmatically access, write scripts, um, write basic, and anybody can learn basic. It's like super easy, and you can control the board and all of its functions. It's very powerful. I'm not going to go into all the features; take too long. And this is the new edition, right? So we've developed for this board a very powerful 3D stuff has been like developed for it. You can see that with these games, right? So these capabilities took a while to develop, but it's hardware accelerated. So what's the use of having an operating system for a microcontroller like the ESP32-S3 if you can't write programs for it, right? So all the things I've shown you, the background, the memory, the system test that we can tap into, the temperature, the PSRAM, the SD card, the audio, the internet, things like that. Uh, you should be able to tap into that and write programs for it. And now you can. So basically, I created something called BlueScript, and BlueScript is like JavaScript except much more simple. And this is the manual for it. It's an SDK for Project Blue. BlueScript is like super easy to use. Super, it's like one line uh, for each command, and it's like it's simpler than a JavaScript and a little bit more than Basic. So it's in between. Um, and I don't know what to say. Like it's super easy. You can see an if then loop, right? For drawing a window, it's super easy. But what it allows you to do, it gives you full access to the system via an API. So it's one command per line, right? It makes it very easy. It's PSRAM optimized, so you have 8 megs to 7 megs to use, right? Not just that half a meg SRAM. Um, and it gives you access to Project Blue's graphic engine. So fill rec, draw circle, draw line, things like that. Really easy to use, and really easy to build programs for. Color palette, 16 million colors, right? some built-in 18 built-in colors, but you can basically audio streaming, all the sound effects for the games, um, access all of the decoding for images, right? Your wget, your network status, get IP, RSSI, file system, right? Make directory, remove, delete, copy, right? Things like that. Directory listing, GPIOs, all the peripherals, write to pin, read from print, um, serial. You can write to the serial port, read from the serial port, remote peripherals. So just how we have Boardmaster, same kind of thing. You can control remote boards like IoT devices remotely, right? Scripted, write your programs for that. Full telemetry, um, get CPU, get chip type, things like that. Let's see, set your app name, full 3D engine, right? Collision detection for games, math functions, right? Sprite systems, which is important for games, right? Networking, again, your file system. So basically, it gives you programmatically full access to the hardware and all the systems we've developed that was developed for Project Blue. So with these scripts, here's a couple of them. There's a clock, right? It looks simple because we want to build something simple to just show you what's possible, right? So right now, this clock is it has a white frame, right? So if we go file, and we go scripts, let's see, scripts, and that's the clock, right? So let's double click it. Now we have the editor. And if you look at the code, it's real simple to make that clock. It's not like 500 lines of code. It's really, really simple with BlueScript. Very, very simple. So I just want to show you that draw circle, right? It's white. So what we're going to do is we're going to make it blue. And we're going to say file, save, to show you that this is like a real thing. Uh, the network is very slow. I don't know if somebody is using the network. Let me just reboot the board. It's very, very slow. All right. 1 second. Okay. Let's go back to scripts. Let's go back to clock. And it's blue. Okay, so it took the change. Okay. So now if you go to script and you run it again, well, what happened there? Okay. Very strange. Never seen that before. Let's give me a minute, folks. All technical difficulties. Make sure my SD card is connected. Yeah. Scripts. And clock. Blue. Okay, good. System. Rescan. Scripts. Very strange. Okay, so what we're gonna do is we'll re-put on File Explorer, go to scripts. I'm gonna delete this. Or actually, you know what? Save. Let's see. No. So let's delete it. Something went weird here. Scripts. Delete. that script back on. Let's go. Scripts. Okay. File. Desktop. Scripts. Clock. Select. Upload. Okay. Should be there now. Okay. Let's go to scripts. Yep, it's there. Okay. So clock. Yep, there's that clock. So the file got corrupted somehow. So if we go to File Explorer one more time, go to Scripts, go here, change to white to blue. You can change any color, I just like blue. I don't know what's going on. It's kind of strange. Okay. I think I got. Oh, I disconnected. I was disconnected. What is going on? Somebody is messing with this thing. Okay. Let's do it one last time. Scripts. Clock. Delete. Yes. Wi-Fi. Put it back on. One last time, folks. Bear with me. Scripts. It's like somebody's playing a game. Okay, upload. Okay. Stop. Okay. Clock. Yep. Okay. And then I'll go text editor this time. Scripts. Open clock. Go to white. Blue. Save. Looks like we found some kind of bug. It's bizarre. But in any case, yeah, disconnected. Some kind of a bug. Yeah, so it's messed up. That's okay. In any case, the scripts, it does work. It was working before. Here's a script that basically tells you the heap size, your PS RAM, and if you're online, what your IP address is. Here's another one. Yeah. So this, you basically, where you click in the box, it shows you your coordinates. So again, this is a script, right? That's being interpreted by BlueScript. So let's go to 3D cubed. So you can make things like this. So you, basically, through the script, you're writing applications that tap into. It's like a glue that taps into the underlying hardware on the ESP32-S3 and all the functions that we've made for Project Blue. It allows this to be possible within a couple of lines of code. So it's not complex to make applications for this operating system. Let's go cube. This is hardware accelerated. So in this demo, we're not doing like one cube. We're doing like a whole bunch, right? 1, 2, 3, 4, 2, 3, 4, 4 or 5 cubes. Cubes within cubes within cubes. So just to show you what the hardware rendering can do on a script level. So these are the kind of things that you can do with Project Blue and BlueScript, which is pretty incredible that we can do this. Particle. Yeah, so you can do simulations and collisions and things like that programmatically. So with BlueScript, it allows you to build applications for Project Blue. You can write your script in Blue Basic in Basic and save it in a text file, or you can write it in Blue Script and save it on your SD card. And the board picks it up when it loads up, and it's able to do this. So, and if your script has bugs, it'll be red. So, Test Explorer, right? So, for example, clock, control flow. Let's change the text here. Control flow. So if I go File Explorer, scripts, control flow. Okay. Let's see. Now let's go. Just say Julian, just to show you that this is a real thing. Yeah, that's saved. It's weird. Anyways. Oh no, it didn't save. So there's some issues with the text edit. Oh, I know why. Oh my goodness. It's in rich text format. It's saving it in a different format. That's right. That's why. Okay, so if we go back to, yeah, it's saving in RTF. Sorry, my bad. So File Explorer. So if we go back to scripts, now we go back here, and now it's blue, right? So if we go save, yeah, saved. So if we go here, yep, there we go. So now it's blue, right? Before it was white. So it was saving in an RTF. It needs to be in text, or else the blue script can't pick it up, right? So there's your clock working, but we've changed the color to blue. Now let's go back and go File Explorer, script. Let's go back and change this to white, right? Just want to show you that this blue script is a real thing. It's not BS. So if you go to clock again, you can see it's white now. So we've changed the attributes, right? So this is a real thing. If I go to one last one before we move on, if I go to control flow, right, and I go file save, okay, so control flow, and Julian, it's such a chip, right? But we changed that. So I just want to show you, like, this stuff is for real. There's no BS going on here. And that we can actually play MP4 files. We can do 3D like Mario Kart almost. Basic ID interpreter, now Blue Script. All these things it's possible with Project Blue. So this is hardware accelerated, right, and pumped through the network. So it's just incredible what you can do. So we're just basically touching. Getting started with what's capable with this microcontroller. And so let's go back to Stardust a little bit. I mean, this is incredible. This is like arcade. And this is over the network, right? So that's the thing. So obviously there's going to be some slowdown sometimes, but yeah, yeah. This is Project Blue. So let's go to control panel again. Take that off. Let's clear that. Yeah. So this is what's possible with this operating system that's been developed for the ESP32-S3. And I'm going to go to browser one last time. Go to CBC, read. Let's see what CBC's got. It's a little bit slow, not as fast as your web browser, not capable. Doesn't do JavaScript or anything like that, but it does do text and images, and that's a pretty good start. That we can have a web browser uh, on a microcontroller like the ESP32-S3 is just incredible. We can do all that 3D stuff and have Boardmaster where you can control IoT devices. Now, these are the things that I was talking about in my previous videos that I've removed from YouTube. And now it's really a reality, right? So, okay, yeah, I mean, it's really a reality. So, I mean, this is a real thing. Text browser. So if you have your and the mouse scrolling, right? I mean, it's not painful to use. It's like super easy to use. Yeah, I mean, it's incredible that we can do this on the ESP32-S3 is amazing. So that's it. That's all I wanted to show you that we're doing here. And I hope you like it. I hope you'll have a chance to check it out. Get one of these boards in your hands so you can see that it really is real. Um, and it's kind of fun. Let's see, what kind of background can we put on? Mountain cat. Let's do this. Okay. Yeah, this is a real windowing desktop running on the ESP32-S3. Streamed by the board, hardware acceleration, man. I mean, it's incredible, right? Real time, true type fonts, right? So let's go huge, let's go blue. Wow, this is amazing. So, and you have all your edit functions and stuff like that. Yeah, so I hope you like that, and the next video will be much shorter. Hopefully, we'll have something cool for you to show you with the scripts and stuff like that. So, have a good night or a good day, and I hope you like what we've done here with Project Blue for the ESP32-S3. Have a good night.